Okay, well, thank you, Tab. Thank you for inviting us to do this, and thank you for having us. Um, this is a really special project for us. It was the first thing that we built in Northern Ireland after moving here as a practice, and it was a collaboration with Donna McCrory Architects as well. And we were delighted that because of all the hard work that went into it from a number of different people, it won a Wood Award last year. We were ecstatic about that. So I'm going to whiz through this presentation to try and stick to 15 to 20 minutes. What is the Built East Pavilion? Well, it's a structure, freestanding structure in East Belfast, and it's still standing. It was built in 2019 in the summer. It was also an exhibition that popped up and popped down a few times, talking about the way it was made and the people involved in making it, which is a really important part of the story. And it was also a research project funded by Queen's University, Belfast and Central St. Martin's as well. So we were encouraged to really look into the processes of manufacturing behind this project and document them extremely well, which was a huge privilege to be able to do that in this project. The pavilion is made of three prefabricated elements: the concrete feet that weigh it down without going into the ground, which David and Paul speak more about, I'm sure. The Accoya timber frame with one side cladded with Accoya as well, including the Belfast trusses, and then the Corten steel roof with some polycarbonate roof lights in that. And each element was designed to reference in some way the industrial past of East Belfast. Each element was also made in a different Northern Irish factory by a Northern Irish manufacturer. So the whole thing was a celebration of past and present manufacturing in Northern Ireland. Because this was the first Royal Society of Ulster Architects pavilion constructed in Northern Ireland, that felt like the right theme to start with. And there have been pavilions since, but we wanted the first one to be a celebration of manufacturing in Northern Ireland. So the competition was called the Belfast Flair competition, run by the RSUA. We won it in 2017, and this was built in 2019 summer. We have to acknowledge the team involved. That's the point of this pavilion. So without going into too much detail, we had BPJ Group doing the joinery, Fabrite doing the roof, More Concrete Products with Banner doing the concrete, all from Northern Ireland. We were also incredibly lucky to work with Donald on the architecture side, and Joe Laverty, who was a photographer who helped us build our research project with the factories and manufacturers. OCSC Structural Engineering will be speaking later, and the primary sponsor was JP Corrie. And as you can see there, the budget, we could dream about something costing that much these days, I think. At the time, it felt like a lot, but now, considering it's been there so long, I think very good value. Just a brief note to say that this project, as I said, it was the first project we OGU built in Northern Ireland, and it's had a huge impact on our practice. We learned a lot in the process of building something in public space, and that allowed us in 2020 and 2021 to quickly achieve several projects in public space that allowed outdoor activity during the pandemic. And we have since completed several such projects. This is a project along Adelaide Street in the city centre, made of local larch grown in Tyrone, another demountable pavilion project, reaching half a kilometre, replacing a lane of traffic with incidental play and seating and planting. And very quickly as well, since we did this project, I've run a studio about demountable and temporary architecture at Queen's University Belfast with my colleague Fergal Murray. And over to the right, we've just put up an installation in the Estonian Biennale about reusing timber and timber components. You can see Chris in there. So it's had a huge impact on us as a practice. Anyway, back to the pavilion. I think David and Paul are going to speak more about the Belfast Truss, but this is where it started. And you can see here is a picture of the Belfast rope works. And this was located opposite the site of the pavilion. And it's no longer there, but it wasn't demolished very long ago. And this was a kind of starting point for our inspiration. These curved timber lattice structures used to be commonplace in Belfast factories, and there were a lot of factories in this area of East Belfast. And so it has a place in living local memory because so many people have worked under these roofs, especially in East Belfast. Here is a photo looking over the site historically, and then a sketch that we did showing the ghost of the ropeworks now gone opposite the pavilion and the difference in size. This is a painting by John Luke of the area in 1934, and it's kind of collage of elements that make up the character of that area at that time. And you can see the Belfast Trust there in the background. And this is kind of the approach to the design that we took, where we didn't want to shrink down a factory and make some kind of strange, something that felt like it came out of a museum or a model of some kind, but it took elements that evoked memories of the industrial past, but put it together in a new way to keep it resonant. And this is just a photo showing just how many people in Belfast would have walked up and down to the docks between East Belfast and the docks of Belfast in its heyday. And on the right, Holland and Wolff timber workshop there under the Belfast trusses. So many people remember. And again, David and Paul are going to talk more about the Belfast Trust, but we were lucky enough to be able to refer to historical drawings and the way that these things were made. And the wonderful thing about them is that they use lots and lots of short sections of timber to achieve very long spans. They're very economical and they're able to reuse timber cut-offs from the shipping industry. So we really liked that economy with material and the idea of reuse and innovation. So this is just part of the text in our entry for the competition that helped us win the competition. And it's just a statement essentially saying what I've already said, that we wanted to celebrate and look at Belfast and things that are unique to Belfast. All too often, maybe we shop around to other places and try and bring things here. But actually, there's a very rich culture of manufacturing and industry here that still lives on. We have an amazing seam of industry and manufacturing in Northern Ireland that we can still draw upon, and we wanted to do that. So this is the pavilion site. You can see that the site is an intersection between a primary route, a vehicular route into the city centre from the East Belfast Newtonards Road, and it's a crossing point between that road and a new greenways cycle routes. And you can also see that the cycle route runs alongside the Connswater River, and that's why there were so many factories in this area, because of the Connswater being there. And not so long ago, the Newtonards Road was a very bustling and lively high street, but as with many places, there was this slight sense of post-industrial loss in the area, and a lot of people remember the bustle of when the factories were there and people walking up and down, and they wanted to talk about it. And so we wanted to make a pavilion that kind of started those conversations and allow people to talk about that in a different way. The client Eastside Partnership are an organisation involved in a lot of regeneration in East Belfast, and they've done a great job with so many sites in East Belfast, and they helped to achieve the CSO Square, which is this hard landscape park, which is the immediate context of the pavilion. As you can see, if you look at the development of the site, it was only completed very recently, and it's kind of this big bowl shape that's so great for cycling and scooting. But that part of the park felt really finished and quite newly finished, and we didn't feel it really needed a pavilion there as such. It would add clutter, if anything. So the location we picked for the pavilion was actually in this small plaza between the main park and the main road. And it receives people straight off of the Perkin crossing. So people come off and slip under it and into the main park. So hundreds, thousands of people have passed under this thing by now. And we placed it there kind of on purpose so that as many people as possible would pass under it. There's someone passing under it on a scooter. What this means, of course, is that it's an incredibly public structure, and it had to be able to take an enormous amount of wear and tear. It was also the first pavilion like this to be constructed in Northern Ireland, so there was a lot of worry from funders and others about whether there would be vandalism, how it would be treated. And so there was this desire for a really high level of robustness for something that actually the brief said it would be a 6-month pavilion and then it would come down. So there's this kind of meeting of brief and reality where, okay, even if it's there for 6 months, we need to make it incredibly robust. But at the same time, need to think about the fact that it may come down and need to be moved. And also it needed to be assembled very, very rapidly on site because it's such a public place. And we think it makes a nice edge to this plaza as you go into the park. So anyway, the robustness, checking the time now to make sure I'm not, okay. We chose Akoya, and Akoya is brilliant. And I think the last presentation was an Akoya project as well, but we chose Akoya because it doesn't require a lot of treatments in order to be robust. It has a 50-year warranty from Akoya itself if it's above ground. It won't rot. And we did actually add a UV protective coating because we were told it may bleach a bit in the sun. But we just added a clear coating and it's been absolutely fine. Apart from that, because I don't know whether you've ever tried to paint a lattice fence or anything, but it's an absolute nightmare. So if we'd given something in the maintenance plan that needed to be coated every couple of years, that would be an absolute curse for the client. So this was brilliant for that. Also, it's not prone to a lot of warping and bending and shrinking. It's quite stable. So again, that just that robustness appealed to us. We also really like the fact that Akoya is made of radiata pine mainly, so it grows quite quickly. So it's replaced more quickly once you've cut it down. The downside with it is that it still comes from New Zealand. And ideally over time it wouldn't come from so far away, but for us on balance, because we didn't know how long this had to be here and it needed to be robust, Akoya was the best choice. And it's weathered really, really well. It's still there 3 years later and it looks as fresh as it did on day one. It's been cleaned once, I think. Moving on and continuing the theme of robustness, we've done projects since that really celebrate the fact that they're demountable and you can take them apart and they show all their bolts. This was not that project. We were very careful to make sure that it wasn't easy to take apart in a way. It was if you knew how to take it apart, but it wouldn't be showing off how to dismantle it because people really weren't worried how it would be treated. It has been treated very well, but I still think aesthetically it was the right choice anyway. For this project. The reason being that one of the biggest challenges design-wise was referencing something so big like an industrial factory and shrinking it down and keeping that fineness and that kind of economy and lightness that an industrial structure has in something that could easily become more like a gazebo or some weird museum feature, because you can't necessarily reduce the timber sections down times 10 or anything like that. And so there would be something about big bolt in the thing that would unscale it or make apparent that it was so much smaller than what it was referencing. So just some photos here where you can see the excellent job that BPJ did and hiding all of the fixings, pelleting them where they were needed, but most of them are hidden on the inside because the truss is sandwiched. You could hide an enormous amount on the inside of that sandwich. So you can hardly see the pelleted fixings either there. And then on the right, there's half of a truss being made and you can see it being fixed on the inside, or the lattice bars being fixed on the inside. Just for comparison, this is the Adelaide Street project again, which is proudly wearing its bolts and showing how it's going to come apart. And that's a later development, I think, on the way that we're thinking now that we know the level of respect that structures tend to receive in Belfast. People haven't, cover them in graffiti or anything like that. So we have a different approach. But as I said, for the Built East project, that wouldn't have been so appropriate. And just to prove there are fixings in it, just a little diagram showing the fixings at top and bottom. And we took that from the historical drawings, actually showing how the thing was fixed. But I'm sure David and Paul will talk more about that. And then quickly, just some photos showing that, yes, it did need to be robust, but not because it was badly treated, but because it's been well loved, I think, and used for lots and lots of different things. Okay, back to the team and the different manufacturers involved. This is just a quick map of Bannermore, Fabric, and BPJ and the site. And I'd said already that our way of designing this thing with a kind of collage, and we were referencing historical parts, but bringing them together into a new whole, so it didn't have this strange museum exhibit uncanniness to it, hopefully, but that it still evoked memories. And so we used a lot of physical models at first, which I still think is a great way of starting out with timber design to make scaled models. And in some ways, we were respectful to history, and we tried to take lessons from how to set out the bars and different details. But one thing you can notice here is that our curve is much curvier than the original larger factories, because the span is so much smaller, and that did present issues, which we felt was worth it for the way it looked. But also, it was so much smaller, and it was a pavilion, so it had a different audience, so it needed to be more finely crafted. It needed to be able to be touched by members of the public without getting splinters and that kind of thing. So there are a few differences as well. And on top of that, we wanted to piece together the different elements in a new way to keep it resonant and interesting. And so we ended up with this zigzag design of the trusses, which was Donald's idea. And I think it's great because you walk around it, and there's like a dynamic sense. It changes a lot when you move around it because of the two angles of the trusses. But what it means is there's two truss types as well. So you have two curves, and then the purlins run directly over the top. So the geometry had to be perfect. It was crucial that it was perfect. Without that, just wouldn't work. It wouldn't fit together. How am I doing for time? Nearly finished. And so we had to work very carefully with the manufacturers to make sure that we had these different elements, and how are we going to make them so that they do reference history enough, but also they do show off innovative methods of construction. And the project that we did with Joe Laverty, the photographer throughout, took portraits of the manufacturers, went to the factories, looked at the process, and I think everybody was on board with what we were trying to do, and it ended up in this exhibition. This is a quote from Fabric there. And that was, that was really important to how the thing turned out. For example, here we have the flat seamed corten roof, which ended up sort of referencing the shipbuilding industry, which is a really clever move from Fabric. These are the brackets that also reference the interior of a ship in the end, the one place where the bolts are expressed. And the other way that we collaborated with the different manufacturers was to make a lot of prototypes one-to-one. Here is the steel, but this is I talk about timber. So when we gave the CAD drawings over to BPJ, they actually CNC'd it all out in MDF at one-to-one, including the floor plan, and set it out. And you can see this prototype here. And that was to look at all the tricky joints and to think about the sequence of how it would be put together on site as quickly as possible. So first of all, how are all these connections going to be secreted away, as I described? And secondly, how can it be taken apart and then put together on site really, really quickly? And so here's the MDF model there of some of the joints and bits and pieces. And there it is. Luckily, the purlin coming across and working okay. One of the things I mentioned earlier was the curve. The radius was such that the idea of bending the Akoya over the top in a bow was not going to work in this case, as they did with the original, which had a much shallower curve in those factories. And so BPJ made the decision to CNC cut those curves. And we weren't keen on the idea at first because there's a wastage involved in that, but there's also a wastage of people's time, and the fact that Accoya behaves very differently to other woods, and it's strong, and it was not going to curve in that way. And the result is brilliant, and it takes in the innovations that we have now that weren't available then. And that's just a photo showing how these curved pieces were joined together. And then the other thing about these factories is, of course, that they're maybe joined together a bit more roughly on site, and there's a bit more room for adjustment and tolerance. With ours, there's no room for tolerance, there's very tight tolerance. And so the angles had to be perfect, especially the purlins came in on site and rested on top of these trusses that were made whole as trusses in advance. And so you can see there that the Accoya took that sharp angle really, really well. But also the MDF template allowed these angles to all be cut perfectly in advance, again, for rapid on-site construction. There is the structure made entirely in the factory before going to site, fitting together like a jigsaw puzzle. And here it is on site, and it was on site. This part took about a week, I think. It was 2.5 weeks total on site. So this is my final slide before I hand over to David and Paul. But there's a photo here of the joinery workshop for Holland and Wolff, who you may have heard of, our famous shipbuilders. And then below is the joinery workshop BPJ and my students there doing the Osmo coating on the timber. And we had this question throughout, like, how are we going to bring together innovation and tradition to make something that maybe feels resonant locally and settles into its place? And very quickly, what we realized is we don't have to worry about that, because when you're working with skilled craftspeople, they bring together in their own mind and in their hands and in their muscle memory tradition and innovation. They just pick it up and work with it. And so it just came through. It just came through because of them and their hard work, and because they were on board with the project. And so that's Stephen there just putting it together. And I'm going to leave it there.
Okay, thank you, Rachel.
David.
Thank you. I'll just share my screen. Okay, hopefully you can see that. And thank you, Rachel. Paul and I were the structural engineers working on this project, and it was a great project to work on, very interesting. And I'll just take you through sort of the structural analysis and how we worked through that. So as Rachel has noted, the Belfast Truss was used in factories, hangars and warehouses, not only in Belfast, but across the UK and Ireland and America, and as far afield as South Africa. It came to prominence in the late 19th and early 20th centuries because of the efficiency and economy for covering large clear spans. It has been used to create clear spans of up to 37 meters. Previous forms of timber trusses became too expensive and cumbersome to construct at these large spans. The Belfast Truss provided a light, easily constructed option that could be built on site using small sections of locally sourced timber. It is now being considered as a possible way to promote sustainable roof construction due to these benefits. Recent examples have been used, such as the sports hall for the Winston School in Gloucester. The slide here shows, again, Holland and Wolff, but also, it was extensively used for aircraft hangars, and this is an example in Aldergrove. But because of that, it was used across the world for RAF facilities in particular. Just moving to the next slide. Yep. Pardon me. We developed our design using the historical examples, such as the image on the left-hand side of this slide. These came from the likes of Andersons and McTeer and Company in Belfast. Andersons became very successful with offices across the UK and in New York. I'll let Paul discuss the intricacies of the analysis that we completed, but these historical examples were vital to our understanding of how the design of these trusses was developed. The roof itself is a barrel shape and was commonly covered with timber sarking and felt. This was supported on purlins, which in turn transferred load to a series of trusses, generally set at 10 feet or 3 meters apart. The trusses comprised a pair of parallel upper chord members, which can be seen on the left-hand side image here. And these are bowed to form the barrel shape. These were joined near the eaves to a pair of straight lower chord members, again obvious on the left-hand image there. Lattice bracing was placed between the upper and lower chords. The lattice bracing was in the form of two interlocking fans. You can see the springing points of these fans at points A and B on the diagram. These points were generated approximately 1/3 of the span below the eaves. The intention was for the internal ties to meet at 45 degrees to the top chord and 90 degrees to each other. And each met at the top chord to then support and hold the purlins in position. Our purlins on this project were set at 450mm centers to suit the cladding proposals. And I'll hand over to Paul to go through the structural analysis. You're just on mute there, Paul.
So this was a fascinating project to work on, partly because it's very outside the limits of our normal structural design, large-scale buildings, linear elastic, with very statically determinate structures. The truss itself had no real comparative structural analysis available to us because the truss type was not previously significantly considered within a traditional stress strain analysis scenario. Trusses like this were generally built by people who simply knew what they were doing. So we didn't have a lot to go on in the first place. What we did have to look at, though, is the effects of the forces on the members and how we could transfer that force effectively through them and get it to work in the way in which we knew it would work, but wouldn't necessarily be obviously shown in our computer modeling. So we chose SIA Engineer, finite element package, as our modeling software, and found that there was some very, very critical issues. One of the most critical things was connections. So normally in software analysis, you would take two elements and just assume a connectivity. Here, though, that caused an overstress, especially in the lath members. So we had to model the flexibility and the ductility of each individual nail and bolt in the connection to allow the slip transfer that would happen between the chord members and the lath members, thus preventing overstressing in the lath members. And at the ends, we had to model the bolt not just as a connective member, but specifically at the location in which the thickness of the members that the bolt would occur, so that it would transfer the stresses correctly across them. And we see on the right-hand picture, you can see the junction between the horizontal chord and the roof chord. And here we can see how the chord is two sections, and there's various methods by which we tried to model this. I tried a single 1D section, we tried 2D stressed elements, and eventually we come up with this single section which contributes parallel members, which would allow us to effectively pass the lath members through the chord while retaining the stability of the members as they would be in the finals construction. Two parallel members created an excess eccentricity in the structure, which caused transfer stress into the lath members, which we didn't want them to do. They were meant to be working as purely axially loaded members, but we're creating a turning, twisting action, which we didn't believe would be there. So there was a lot of experimentation in modeling to find something that we felt adequately transfer stresses in the way in which we would expect. And then on the next slide, what we see is the juncture of the lath members to the top of the chords. And what we did here was we passed the members through and joined them rigidly at the top, which we thought was appropriate. But if you look at the left-hand side picture, you'll see the two lath members. These are the same pictures, just one is expressed in its physical dimension and one is not. On the right-hand side picture, you'll see a small highlighted pink element, and that is shown on the left-hand side picture as a thin member connecting the cord to the lath members, and that is the nail. So we modelled every single nail in the structure individually with the correct thickness and stress properties, so that we would be able to allow for the ductility of the nail in the movement and therefore transfer stresses between all the members. And in this way, we were able to get a more sensible distribution of stress and the members in the lath diagonals to act in a more axial fashion, as opposed to taking bending stresses, which would have resulted in much thicker members. And then finally, the thing I'd like to talk about is the connection of the laths themselves. So what we did was, we first of all tried to model the lath side by side where they would overlap, and that created forces of bending because we now had an offset between the members. So in the end, we modeled them in plane to each other, allowing them to slip past within the element, slip past each other in the truss, thus allowing the concept of the members acting as individual diagonal members, except restrained at the top and bottom. And this worked much, much better because the members would be twisted very slightly at the top so that it would come into plane, where overlapping each other during the actual main body of the truss. But the effect of that is minimal compared to the idea of creating an entire offset where we'd have to double the thickness of the gap between the two cord members and create an additional eccentricity, which was unrealistic and more founded stress failures. And the final thing we did was we had to allow for some 2D shell element timber panels at the very corner of the junction between the cord and the columns, because there was going to be an overload. We assumed a rigid connection at that point because there's very small stress strains, and so therefore it was going to be effectively connected. However, that did create, by restraint of rotational capacity, it created a shear in the members and would have caused excessive shear failure. We knew this wasn't realistic because these trusses exist. And when we looked at it, we discovered in the old drawings, they did actually allow for some gusset boards. So we entered a thin 2D shell element of stiffness, but no real thick properties, because we didn't want to transfer forces into it. We just wanted to act as a restraint to the top cord to prevent rotation of the top cord and therefore prevent stresses. And in this way, we were able to, after a lot of experimentation with the modeling and trying to get new methods of structural analysis, which is FE analysis, to work on old historic industrial form of design, which hadn't been well mathematically recorded, we were able to get it to work in a manner and fashion that we believed was correct and complete the design adequately to give us the solution that we were looking for.
Okay, thank you, Paul. Just going on to the other elements of the project. During the very short construction period, as Rachel has said, it was only 2.5 weeks on site. It became apparent that there was an amount of sway in the frame, which is expected, but it was considered that we needed to tighten this up slightly. And we looked therefore back at historical drawings and calculations again, and it is apparent that some examples did have knee braces as such, and these can be seen in the corners between the columns and the bottom cords there. So we worked with Rachel and Chris and the contractors to develop a design of the knee braces, and these were formed in Corten steel, which allowed them to be fitted between the laminate of the column and the cords, and also to blend in with the covering. And so they effectively cut out any sort of sway issues that existed. Moving on, this is the last slide, just to talk about the foundations. The brief for the foundations were that they couldn't impact on the newly finished public realm paving scheme that was on the site, and they had to be transportable to be relocated to another site. Again, we worked with Rachel and Chris on this to develop the size and shape of the foundations. The individual foundations shown on the right-hand picture were designed to prevent people being able to climb up them, and also to stop people being able to push them over, but also to spread the loads on the paving slabs to avoid damaging them, and also to avoid the existing surfaces. And you can see the manholes either side of the foundation here, and also to resist the uplift forces that were one of the main force issues on this project. The strip foundation on the far side of this picture were developed as a bench seat, and again to spread the load along the paving. And everything again is demountable and can be taken away without any sort of damage to the existing paving on site. The concrete specification for the foundations was developed collaboratively with Moore Concrete and Bana UK to create the colour and texture that is shown in these photographs. I'd just like to say, for a small temporary structure, the design provided many challenges, and it provided a chance for us to look back at historical designs and learn from the engineers of old, which was a welcome challenge to us all in the office. And yeah, that's us finished there now. Hand over to Tabitha.
Brilliant, thank you all. So, well, Liam's going to spotlight us all. I've just had some corrections from my team. I never introduced myself at the beginning, so I'm Tabitha Binding. I'm Head of Education and Engagement at Timber Development UK. You can find me online. Come and ask us sort of any questions at all about timber. We're connected to a lot of people, and also the Wood Awards at the Oxo Tower is open to the public. So if you're in London for the sort of 4 days that it's there, yeah, please go along. Thank you all, and amazing. I love it. I just love Belfast trusses. I love innovative uses, and there's so many different things I think we could talk about. So the Accoya was used for the Belfast truss as well as the supports.
Yes.
Yes.
Yeah. Yeah. Was it strength graded, or did you have to then actually grade it?
It was strength graded, yeah. So yeah. Mm-hmm.
Yeah. Or just to C16, C24, or to
yeah, well, we worked to C16 on that.
Okay.
Yeah.
Yeah. No, that's what's known. And so it came up time and time again about sort of collaboration. What I suppose, what did you take away from this whole process that has been beneficial, I think, to your, to further projects, or how you've then gone on to work since? And I think that's for all of you, So.
Okay. Rachel and Chris, do you want to go first, or?
Wow, that's so much. I think, Chris, do you want to come in with me on this one as well?
Yeah, I think what's been lovely is working with in a very kind of hands-on way. So I think maybe some of the in the joinery workshop, there's a lot of there's a kind of coming together of that sort of process of using sort of heavily engineered ways of cutting timber, like CNC machines. But it was actually quite the sort of old sort of tactile ways of making trusses, and actually trying to perfect details on site, which was the thing that was really a sort of nice thing to work with craftspeople who had this sort of memory of working with trusses and getting those final details right. Even though they were heavily engineered, it was actually that sort of historic nous of guys that had previously made trusses bringing it together and using that expertise, which was really a sort of nice thing that we've managed to bring into other projects then afterwards.
We're always in factories now. I think we discovered so many great manufacturers in Northern Ireland through this project, and now any excuse to be in the factory, and we're there, aren't we?
Yeah, I think that's something hugely important to other projects, and particularly with the pandemics, allowed us to work with these manufacturers again and sort of find ways of doing things quickly, prototyping elements. And because of the scale we work at, it's not necessarily like making a building, and you can work through sort of prototyping elements and details and to make these external structures in a way that you know, this project has given a lot to us in that regard.
Yeah, I'd just like to add to that, in that, you know, in the sort of research of the Belfast Trust in particular, you know, what I've sort of learned is that, you know, like McCrory company and Anderson's, one of their sort of advertising sort of slogans was that, you know, this could be built anywhere. And, you know, they effectively had teams of men in those days, you know, back in the 1850s and up to 1900, that would travel around and could build these trusses on site across Ireland, across the UK. They didn't have to take the materials with them. They would source the timbers locally and then work with them and build the trusses on site. And, you know, we're kind of reverting back to that now. You know, the sustainable element there is, we're trying to achieve that. And that's feeding into a lot of projects that we're working on at the minute, is, you know, locally sourced materials.
Yeah, we've just one of the projects that Rachel has just shown is on Adelaide Street, and we were quite surprised whenever we were able to actually work with and use a local larch. You know, so I think we worked it out that between where it was grown, where it was milled and manufactured, I think it traveled 115 miles, which to install, which I think was pretty good. But again, that sort of relied on you know, the sawmill and, you know, guys with good knowledge of timber, sort of selecting it properly. You know, you're not going to get it stamped in maybe that same way that you know, you're sort of used to getting imported timber. So and that was nice to sort of see and work with guys who are literally cutting timber to select the right bits to do the job you want to do. You know.
You got anything to add, Paul? Yeah.
Yeah, well, in a strange sort of way, not so much the collaboration, because it's been well covered by David and Rachel and Chris, but it was a strange sort of thing to almost feel like I was collaborating with people from 100 years ago, because I had these drawings to work off, and although I had no mathematics to go on, we had a very clear guide to their thinking. And I'm thinking, well, I'm actually, you know, people have left behind their thought process for me now to communicate with. And that in itself was an interesting thing.
So how do you learn to communicate, you know, together? Because I noticed here, so Rachel talked about pelleted fixings, and obviously you're talking about bolts and screws and nails, yes. You know, so suddenly you've got that terminology, and how do you?
Well, I mean, I personally thought that from the outset, the key thing is to have shared objectives. So that was the key thing. We entered into this with the idea of creating something good, and with the view on the aesthetics of it and what it would mean. So in other words, the only way it would work is if we bought in to Rachel and Chris's vision in the first place, as opposed to, and that's always the risk with a small project. The risk is always that people will look fee first and what can I squeeze out of it for me? And then it would have been a disaster, I think. Less so from our perspective, but much more so from the manufacturers, the people Rachel got to work on the actual construction. If they had been interested in only bottom line, this would not have been a successful project. So I think that's the idea. The key thing was to go with the vision and subscribe to what we're actually trying to achieve, as opposed to just a pure business bottom line perspective.
Yeah, no, I think just to reiterate that, I think for such a small thing, it's incredibly complex, and everyone really enjoyed the research of it. So to get you know, carpenters to be able to sort of bring these kind of weirdly angled trusses together, and then have, you know, very complex metalwork, you know, meet those angles and have that all come together on site in the matter of a couple of weeks is pretty impressive. And it was great to sort of meet these people, and then you use all these people and you use all the knowledge again on other projects, which is, you know, whatever, everyone was sort of buying into the research, or it wouldn't have happened.
Yeah.
Yeah, that's so heartwarming hearing that. So you're all bought into it. You share the good things and the bad things. It's almost like the pain and the learning, but you all get, you know, something out of it at the end. But you also potentially get to work together. But obviously, building it at one-to-one scale in you know, MDF was you don't often get that opportunity, do you? It's
No. It's true.
And do you think this has changed you? So as architects, so I mean, obviously, forgive me for this. You know, architects can sometimes drive a project and get really embedded in their vision, and don't necessarily listen to their engineers and the contractors as much. Do you think that's changed how you?
Yeah, I would say so. Would you say so? I mean, we're always in a factory, and we have particular manufacturers that we really like to work with. And I think over time you build up a relationship where they can second guess a little bit what you're trying to do as well. And so I think those conversations are, I mean, they're fascinating when you start to learn. Well, I mean, the Adelaide Street project, for example, it was like almost like a product design. It was quite different to the Built East Pavilion, and you start to get into, you know, what a brake press does, and therefore how you can bend something in order for it to work. And it was so precise, and you have no choice but to get into all of that in order to be part of the design process. Otherwise it's not going to turn out at all how you envisioned it.
And I do think probably there's a culture of manufacturing that exists in Northern Ireland that's still there. And so it's nice to work with us. We work probably at a scale where it's, you know, it stays out of that sort of very contractual realm, and the guys we're working with quite enjoy sort of exploring, you know, pushing the boundaries of a material or getting the detail right, and they get used to working with you, and you get used to understanding what they're good at and what you're not, and you fill each other's the gaps in knowledge to get to these sort of great ways of putting things together. So that's something we've sort of taken out of the project, is meeting a lot of these people we now work with a lot for the first time on this project.
And as engineers, I mean, I'm assuming it's changed the way you view architects and manufacturing. And
no, I think as I was Chris is saying there, it was a different type project than we're all probably used to, like in the scale and the nature in which the workmen sort of got into it, and they got stuck into it and brought out their expertise. It was something different for everybody, I think. And as Chris said, it didn't get into the sort of contractual sort of size of job that you're looking at, you know, continually at the amount of time you're spending on it and different things. You know, it was to create the finished product, you know. Yeah.
I think that's probably one other thing just to add on that, is that we find with these type of pavilion projects or these external projects that it does become more like product design in some ways, because there's no element of it that isn't exposed. So the structural engineering and the detailing of it is incredibly important, and you know, sitting around and getting those things right, and then trying to get craftspeople to buy into making them in a way that is, you know, beautiful. That's what makes the project, and everyone, you know, David, Paul, and you know, bought into that, and we sort of, and then the manufacturers also bought into that because they kind of understood that historical aspect and the sort of Belfast Truss element of it and where it was coming from, and yeah, that was a nice project to work on in that regard.
So we'll go to question and answers. So if anybody else has got any, please pop them into the chat. I'll read them out. I think I actually got a couple of potentially engineering questions here. But before we go to that, you mentioned a sports hall in Gloucester. Now, is that in Gloucester, Ireland, or Gloucester, England?
England.
It's
in England, yeah.
Fantastic. Yeah. I mean, we'll be asking you for some links to that and some. And did you work on that? Did you work on that?
No, it wasn't one of our projects, but it was just, you know, when you're researching these things, there were examples coming up, and yes, there was, and it again was quite a collaborative exercise in that, you know, different people got to work on the trusses, to form the trusses and to build them, rather than just the pure manufacturers. So it was a good project, yeah.
Yeah, no, brilliant. So we've got a question here from Michael. Well, it's quite, it'll appear at the screen. Where did you get your material properties from for the Accoya? Did you do sample testing, and was there much variability in the material properties? Did you fit any strain gauges to confirm your analysis assumptions?
Okay, I guess that's a question for me. So the last question, no, we didn't do any strain gauges, but there are reasons for that. I've done quite a lot of experimentation with university students, undergraduates, doing timber structural design and experimentation. So I knew a little bit about where or when we might have to do such a thing. Now we'll go back to the start. We got the information from manufacturers. So we manufacture standard information on the properties of the timber. And the critical issue was not to bring it anywhere close to a limit. So we want to be well below the limit, which gives the, I mean, of course, we did standard safety factor design as well. But apart from the safety factor design, it was not designed as we normally would. And that's a bit unusual. If you design a big steel building, you'll design it to 1.0 unity factor or very close, because your economy of use of material. Here it was the opposite. I wanted to make sure that the building, the truss would not be anywhere close to the limits of the timber and not risking any excess strains. So the idea was to keep the strains very low and therefore low stress in the members. And that's what I believed would have happened. I didn't believe any of these trusses would have had members that were highly stressed, because we would have had quite a lot of historical failures. So it was obvious from the beginning, whatever way this was, it was low stress to begin with. So I had to find analysis which showed that that was the case as such. And that's really it. So manufacturing information for the timber properties, a design which dictated and showed low stress in the members, and therefore no real requirement for limitations in strain, because from previous experience, we were never going to be in a region where strain gauges would give us any valuable information.
Thank you, Paul.
Yeah. Mm-hmm.
Yeah. David, did you?
No, well, I suppose I just add to that that any failures that there were historically were due to rot, really, rather than overstressing. So that's what we've seen in the sort of history of the Belfast Truss. Yep.
So rot from like water ingress where
yeah, particularly at the eaves, just if
Yeah.
it was a multi-span building and you've got gutters, internal gutters that where I'm going with that. So yeah, yeah.
Flat roofs and internal gutters.
Yeah.
It rains a lot in the UK, and if you don't maintain your buildings or you don't design them to shed water, then timber and any bio-based materials will suffer. Or I mean, steel will too, and as will concrete. But but bio-based materials more. We have a question from Gary. Was there a structural requirement for the sawtooth grid of the trusses, or was this purely an architectural aesthetic requirement?
It was primarily a architectural aesthetic requirement. The diaphragm action of the roof paneling was what we were using mainly for the bracing element of the roof. And maybe Rachel and Chris can discuss the layout of the trusses, because that was more architectural, shall we say?
Yeah, it actually it came from a gesture of welcoming people into the square. So we angled the first truss in order to step back from the square, to kind of gesture people, to kind of guide people into the square from the crossing, and then that kind of set up that geometry, shunting the other trusses back, and then through modeling, having the orthogonal, we say, and the diagonal, it does something visual and interesting when you're moving around the structure. It gives it a kind of depth and dynamism. So
I think Rachel touched upon this earlier, but we modeled this a lot. Whenever you're referencing something that is, a very large scale shed architecture, and then you're trying to do something that's much smaller, there's a kind of architectural atmosphere you're trying to replicate, and we found that there's a certain number of trusses. If trussiness is a design term, we needed to add more trusses. There wasn't, so I think that was part of the sort of that we model, kind of through the modeling process. I mean, it has some structural benefits, but yeah, it's more of an architectural one to give that kind of feeling of being in a heavily trussed building, whilst it being quite small and it being a pavilion.
And I'll just add, the answer to the question of whether the sawtooth orientation of the laths was structural or not is both, or architectural, is yes and no. In our design, in our particular truss, it was architectural. The layout was for the look, feel, aesthetics that Rachel and Chris wanted to achieve, as they've gone into detail just now explaining. From a structural point of view, historically, yes, as in the truss itself, the way in which the truss is made, the sawtooth design is created, I don't know, 100 and something years ago by people who had really obviously thought about it and thought, we have these small, light timber sections. My understanding is a lot of these laths came from packing. And so they were throwaway packing members that they said, well, can we use these packing members? And they reused them to the roof. But that means they were limited with the size of the packing member. And if you tried to make a traditional truss out of those, you would bust them because the stress would be too much. So this orientation, the sawtooth orientation, is designed to create a near continuous diaphragm out of very light members which were otherwise being thrown away. So yes, there was a structural purpose, but not specifically for ours thought through. We didn't dictate one. The structural engineer did not dictate the pattern on this occasion, but historically it will have come from a need.
Thank you, and we've run out of time. Didn't that go quickly? So huge thank you to our team behind the Built East Pavilion, so Rachel and Chris and David and Paul. So this is being what's the word I'm looking for here, because my screen won't move forward. It's being recorded and it will go up on our Timber Development UK YouTube channel, where you can also catch up on the Modelling College, the Welcome Building and the Wooden Annex. Thank you for attending our Design Timber series. Watch out for all the announcements around Timber Development UK. We're going to have a new website, new magazine. It's a completely new brand. It's not out in the public domain there, so yet you're all seeing it at the bottom left there. Come and say hello to us. Obviously, we have the Wood Awards exhibition at the OXO Gallery. So that's the 22nd to the 25th of September. We will be at UK Construction Week from the 4th to the 6th of October. And we're based at the Building Centre in Store Street in London. Thank you for giving us your time and look forward to seeing you again. Thank you very much.
Thank you.
Thank you.
Thank you.
Bye.